So it says if the point x comma root 3 over 2 is on the unit circle, what could the value of x be? Okay, so just a real quick refresher. When it comes to the unit circle, we can use all kinds of triangles, but in high school we focus on two special right triangles, right? So trigonometry is all about right triangles. So the first one is this one here. And this is what we call the 45, 45. Okay. And the ratios are 1, 1, and the square root of 2. Okay. Because this is a isosceles triangle, that means it's going to have two congruent sides. And if we think about the unit circle or the ratio or proportion, it's 1 times x, 1 times x, the square root of 2 times x. Okay, so that's one. Now the other one is, if I do, that's a little too long actually. I want to try and draw this to scale as much as possible if it's possible. The other one looks like this. And this one is 1 to the square root of 3. And this one is called the 30-60. So this is 30 degree and this is a 60 degree. Now, that can also be rotated and to be a 60-30, which is basically you're just standing it up like this. Where this is 60 degrees and this is 30 degrees. The ratios are still the same though. This is 1 to the square root of 3. Now, 1 is the shortest side, 2 is across from the hypotenuse, or I mean the hypotenuse, which is across from the 90-degree angle, and the one that's left over is the square root of 3. So it's really easy to remember. It's 1, 2, root 3, and then 1, 1, root 2. So anyways, we have a y value that's root 3 over 2. So think in terms of x comma y, okay? So what that means is if I graph this, on the xy plane, it's probably going to be either the 30-60 or the 60-30, right? So I have to figure that out. But I know what the ratios are, right? So, well, how do I know what it is? Well, on the unit circle, for the unit circle, your x value can be found by taking cosine of theta. And y can be found by taking sine of theta. We kind of glossed it. Well, we did it on the first example problem. So then when I look at this ratio of root 2 or root 3 over 2, that's my y value. So my sine value is root 3 over 2. And you have to remember using SOHCAHTOA, right? SOHCAHTOA. What's that tell me? That tells me what sine is. That tells me that sine of theta is the opposite over the hypotenuse. So this is equal to the opposite over the hypotenuse. Okay, so what one has root 3 as the opposite? Well, this one does. This is the opposite, this is the hypotenuse, and this is the adjacent. So what I then have is a 60-30. So I have a a triangle that looks like this, where this is a 60-degree angle, and I have this point up here. And this is root 3, this is 2, and this is 1. Now, if I want to find the x value, remember that ka of the SOHCAHTOA cosine is the adjacent over the hypotenuse. So I'm looking for the adjacent over the hypotenuse, which is 1 over 2, right? Because we're using this triangle, because that has root 3 as the opposite, and 2 is the hypotenuse. So then this point here, it's 1 over 2, comma, root 3 over 2. So A is the right answer. That's it. Now, well, we'll just leave it at that. I was going to pull up a unit circle, but that might be confusing.